Hi, my name is Philip. Today I will present the topic of periodic high-utility item set mining. It is a topic in data mining. So if you want more information about what I will talk, it comes from this paper. And also if you want the code and the data to try the algorithm, you can look up for the SPMF library. It is an open source data mining software, and it provides the code and the data. I'm the founder of this software. So let's start. A brief introduction. There are many algorithms that have been designed to find the interesting patterns in the data. This is what we call pattern mining. Okay, you have data and you want to search in the data to find the patterns that will tell you something or reveal something about your data. Maybe it could help you to understand the data, take some decision, or maybe do some prediction. So a popular task in recent years is high-utility item set mining. The goal of high-utility item set mining is to find some sets of values in your data that have a high utility. High utility means, for example, yield a lot of money. Okay. However, there's a limitation with this. It is that it does not consider the time. But in the real life, let's say you look at the shopping data, the time is important because the behavior of the customer will change over time maybe, or will remain the same, but it tells you something more if you consider the time. So today I will talk about an extension of periodic high-utility item set mining. I will present, and I will explain how it works briefly. That will be the topic for today. So what does it mean, periodic? Okay, briefly. Periodic means something always repeat over time at more or less the same frequency, like every week. Maybe some people buy tomato, wine, and cheese. Okay, that will be a periodic pattern. So in this topic, we will try to find the periodic pattern always appear in the data regularly, and also have a high utility, make a lot of money. Okay, so let's start. First, I will take some example to make this easy to understand. Let's say we have a set of items we call I. This will be, for example, the products in a store. I will use the example of a store to make this easy to understand. So here I have the set I, and the items are A, B, C, D, E, F, G. And we will say that these are the products, like A is for apple, B for bread, C for cake, D for dates, E for eggs, F for fish, and G for grapes. Okay, so let's say we have a store with this kind of items or products. Now I want to explain what is high utility item set mining. The input of this task is a database about the transactions, like what the people buy in a store, for example. We could also apply this to other things. Okay, A, B, C, D, E, F don't need to be the products in a store. It could be other things, but I will use the example about shopping. So here we have a transaction database. So let me explain this part first. The transaction database has 5 transactions from some customers. The first customer, he bought one apple, A1, okay, 5 B, 5 bread, 1 cake, 3 dates, 1 egg, and 5 fishes. Okay, so we have other transactions like this. Could be from the same customer. Let's say the same customer buy different products every time you go to the store. Now also we have another table we call the unit profit table. This table tells you the amount of money for each item, the profit. Like apple, if you sell 1 apple, is a $5 profit. 1 bread, $2, 1 cake, $1, and so on. And then in this problem, the user needs to set a parameter we call the minimum utility threshold. min util. Okay, it is a number, positive number. So let's see what happened. The output is all the high utility item set. The item set that have a utility, the money, greater or equal to that threshold, the minimum utility. Okay. So let's say we set this parameter to $33, then the result will be what you see at the bottom. Okay, 4 high utility item sets. So we try to find all the sets of items people buy together make at least $33. So the result is like this. BDE together, bread, dates, and eggs, make at least 36. So it is a high utility item set. BCD together make at least 33. So it is also a high utility item set, and so on. So why we do this? Let's say it's for shopping. We want to find the sets of products people buy make a lot of money. So maybe if we find this information, we can use this to take decision, and also maybe do some marketing, try to sell the product that make the most money together, or give a discount. So I did not explain how to calculate the money, so let me explain this more clearly. Let's say we want to calculate the money, the utility for the item set BDE, bread, dates, and eggs. So how to calculate, okay, the utility of BDE? We need to find where BDE appears. So BDE we have in transaction 1 and transaction 2. So first we look at the first transaction. We must have BDE together, okay, it is important. So here we have B, 5 bread. And in the other table, the bread is a $2 profit. So 5 multiplied by 2. Now, in transaction 1, we also have D, 3 dates. $2 each profit, 3 multiplied by 2. And 1 egg, the egg is a $3 profit, so 3 multiplied by 1. Then we do the same for the second transaction for this part. So it will give us the total BDE as utility of $36, the profit. Okay. So I think this is easy to understand, right? Okay, let's continue. So high utility item set mining is a popular problem in recent years. There are many algorithms to solve the problem. So why this problem is interesting for the researcher? It has some special challenges. So first, if we want to find a high utility item set, we need to search for the different combination, like what we call the search space. Like we can have A, apple, B, bread, C, cake. Then the combination like AB, AC, AD, BC, BD, ABC, ABCDE, and so on. Okay, there are many combinations. So one challenge is that we don't want to look at all the possibility if we design an algorithm to solve the problem. And also the utility is not monotonic or anti-monotonic. Okay, so what does it mean? In a simple way, if you have the utility of an item set like BD, the superset of BD like BCDE or ABCDE, the superset of BD can have more money or less money. Okay, so 30, more 40, or less $25. So if you have like BD, you don't know the superset will have more or less money. Okay, so this is a special property in this problem. So why is it like that? Briefly, okay, because if you buy more products like BCD, maybe it makes more money because you buy more things. Okay, but if you buy more products again like ABCDE, maybe the money will decrease to 25 because there are less people that will buy all these products together. So this is why it will decrease. Okay, this is just to give you the main idea. Now, to solve that problem of high-utility item set mining, there are several algorithms like two-phase, UP-Growth, FHM, and others. Okay, so the main idea for this algorithm, they will use some upper bound on the utility that will be anti-monotonic to reduce the search and find the solution. So today I don't want to go into details about this algorithm because I explained this in other videos. Okay, I want to focus on what is new for the periodic high utility item set. If you want to know more details about the very specific details, you could check the paper or the other videos about high utility item set mining. Okay, so let's continue. So high utility item set mining is popular as many applications, and it can help you to find the profitable item sets where the people buy, make a lot of money. However, there's one limitation I want to talk today. It is not designed to find the recurring customer behavior, something will repeat over time. For example, we could want to find that a customer buy the wine and cheese every week. Okay, so this is a habit. The customer every week buy the wine and cheese together. So a pattern like this always repeat. It is what is called a periodic pattern. And on the other hand, there are some paper on high utility pattern to find a pattern with a lot of money. Okay, and periodic pattern is the pattern always repeat. So in this work, we combine these two ideas together and we improve also to find the periodic high utility pattern. The pattern make a lot of money, but also always repeat over time. They are periodic. Periodic means repeat over time. So let's see how it works. Okay. First, if we want to do the periodic high utility item set mining, we need to have a way to measure the periodicity. Periodicity means the property of something always repeat over time. Okay, we need to define what it is to be a periodic pattern. We need to find a way to calculate. So there have been several papers on periodic item set mining, not for high utility. So all these papers, these algorithms, most of them, they use this definition. They will say a pattern is periodic if it has no period that is greater than a parameter we call the the maximum periodicity selected by the user. So what does it say? Okay, I try to explain more clearly. There will be a pattern repeat over time, let's say every week. Then the user will set a parameter, let's say every 2 weeks. Okay, and if the pattern always appear within 2 weeks, always repeat, it will be periodic. So this is the brief idea. Okay, now I want to show you the example to make it clear. Okay, I will show you how to calculate also. So to explain this, I will take an example. It is another database, but it has the same format I showed you just before. Okay, so but here something I need to say is that we have 7 transactions and they are ordered by the time. T1 is the first transaction and T7 is the last one in the time. Okay, so now if we take one item set AC, we need to calculate the periods of the item set. The periods is the time between each occurrence of the item set when it repeats over time. So let's have a look at this. Okay, first we start from T1. We find that AC appear in T1. We look for the item set AC. Okay, so AC appear in T1, And here, this is a special case. We suppose that maybe AC appear before T1, like at T0. But we don't know what happened before, okay? So, we say 1, okay? This is the time between the last time AC appear and now. We count in terms of number of transactions, okay? So maybe it appeared before at T0, and plus 1 at T1 we have AC. So we put a 1 here, okay? Now we continue. You will see how it works, okay? After that, AC appear again in T3, okay? So from T1 to T3, there are 2 transactions. So we put a 2, okay? T1 plus 2 means T3. So we'll put a 2 here. Now after that, do we have AC again? Yes, in T5. So we have AC here. And again, it is 2 transactions later. So we will put a 2 here. So we have 1, 2, 2. Now after that, we have AC again. 1 transaction later. So we put a 1 here. And finally, this is a special case, okay? We take the last transaction, T7, and we do minus the last transactions that have AC. So T7 minus T6. So from AC to the last transaction, there's 1 transaction, okay? So we put a 1 here. So the first and the last period, they are the special case, okay? So this is how we calculate the periods of an item set, according to the traditional definition. So now we take the maximum of this. It will be what we call the maximum period of AC. The maximum here is 2, okay? So the maximum period of AC is 2. So in the traditional definition in periodic item set mining, if you say max per equal 2, this will be a periodic pattern because the period are never more than 2. If you say the maximum periodicity, the parameter is 1, then this is not a periodic pattern because AC is not, because sometimes it is more than 1, okay? So how to interpret this, okay? This means every like 1 or 2 transactions in the database, we always have AC repeat, okay? Okay, so let's continue. So we could use this definition of periodic item set mining for the high utility item set mining. But there's a limitation with this. It is that an item set will be automatically discarded as non-periodic if it has a single period that will be greater than the maximum periodicity threshold. So if you set the maximum periodicity to 2 and an item set appear after at 3, okay, just a little bit more than 2, automatically it is eliminated. But in the real life, maybe a pattern is always periodic, but only one time it is more than 2, then is discarded. So this is too strict, okay? So we propose in this paper another solution. It is to be more flexible. So we will use 2 measures, novel measures, called the average periodicity and the minimum periodicity. So average means we look the item set, is it on average about periodic or not? So on average, does it appear every 2 weeks? Or on average, the people buy every 10 transactions and so on, okay? So this is why we use the average, to be more flexible. So here, for the periodicity, I have to say we use the number of transactions, but we could also use the timestamp. It will also work, okay? So let's look at our novel definition of periodic pattern. We say an item set X is periodic if the average of the periods of X are between some minimum and maximum. The minimum and maximum are some parameter set by the user. And also, the minimum period of X, the smallest period of X, is at least greater or equal to the minimum periodicity, a new parameter. And the maximum periodicity is smaller than max per. This is the traditional definition. So here, this part is new, okay? So to give more flexibility. And of course, now we have 4 parameters. We don't need to use all of them, okay? If you don't want to use the maximum periodicity, you can set this parameter to infinity, and so on, okay? So it gives more flexibility, because you don't need to use all the parameters. You can choose which one you want. So here, for my example database I have shown to you before, I have calculated the periodicity for different item sets you can see here, like B, BE, and here we have AC. So AC, it has a support of 4. That means it appears 4 times in the database. AC has a minimum periodicity of 1. So the smallest amount of time between 2 AC is 1 transaction in the example. The maximum period of AC is 2, and on average AC appear every 1.4 transactions. So this is something interesting. You don't only look at the maximum period, you look at the average. It can tell you some great information, like on average, the people buy a CD every 1.7 transactions, and so on. So there are also some more theoretical details about this, okay? I will not explain all the details here. I just want to give you the main idea. But if you want more details, you could check in the paper for the proofs and everything. So here we have some theorems we will use in the algorithm to reduce the search space, okay? So I will just tell the basic idea, okay? If you have an item set X in a database, X and its superset will not be periodic if the maximum periodicity of X will be more than the maximum periodicity. So this is what has been used in other papers. It's not something new. But now we have a new property here. If X is an item set that appears in a database, X is not periodic, and all the supersets of X, if the average is more than the maximum average. So this is a new theorem that will be used in this algorithm, the algorithm I will explain, to reduce the search, find the solution. So in the paper we present a new algorithm called PHM. It is based on the FHM algorithm for high utility item set mining. The PHM algorithm will find all the periodic high utility item sets. It will do a depth first search. So first it will search from the empty set, like you buy nothing. Then A, apple. Then apple and bread. Apple, bread and cake. Apple, bread, cake and dates. Then go back and go to ABD. Then go back, AC, ACD. Then go back, AD. Then after this, we check everything starts from apple. The algorithm will start to search from bread, B and C, BCD, BD, and so on. Okay, and this is all the possibilities if we have 4 items, A, B, C, D. Okay, here I did not put all the items, otherwise this will be too big for my PowerPoint. So the PHM algorithm will start to search in this search space, and then use the theorem about the periodicity that I just talked about to reduce the search. And also it will use the other theorem I did not introduce about utility from other paper to also eliminate possibilities based on the utility. So here I give a little more details. Okay, the PHM algorithm is based on FHM, a fast algorithm for high utility item set mining. And in PHM, for any item set like AC, we will calculate the list of transactions, what we call the TID list, the list of transactions that contain AC. So AC appears in T1, T3, T5, and T6. So if you have this, you can easily calculate the periods. So it will be 1, 2, 2, 1, and then 1 for the last transaction is a T7. Okay. So using this TID list, we can easily calculate the periodicity and also reduce the search. So I will not explain all the details. If you are interested by this, you can check the paper or check the code. As I said, you can download the code and the data to try it. So this is the code of the algorithm. Actually, it's not very complicated. I will not explain today. It will take too much time. Okay, but I just want to give you the brief idea. So in the paper, we did some experiment to evaluate the algorithm. We use some database. The three first one, retail, chain store, food mart, are about shopping, and mushroom is a data set about mushroom. It is not related. It's just to do some performance experiment. Okay, so we choose this database to do the experiment for the time, for the algorithm, the memory, and so on. Okay, so these databases have different characteristics, like the number of transactions. They have different number of items, and the transaction have different length also. So let's have a look at the experiments. So for this experiment, we compare PHM, the new algorithm, with FHM for high utility item set mining. FHM find all the high utility item set, so it is interesting, and PHM only find the periodic high utility item set. So PHM will always find less item set than FHM because PHM only want the periodic item set. So in the following, we have 4 parameters for PHM. I will write like this: PHM V, W, X, and Y. It means minimum periodicity equal to V, max per equal to W, mean average to X, and mean average to Y, max average to Y. Okay. So we did some experiment. I show you briefly. Okay. Here we have 4 databases. Okay, 4 charts, and we look at the number of patterns when we change the minimum utility. And I have FHM or PHM with different parameter values. So the blue line is all the high utility item set. And then if you find only the periodic, there are only a few patterns. You see the line is very, very low. Okay. The other data set, it is the same thing. Here you have the high utility item set. There are a lot. But when you use PHM with different parameters, you will find only a few periodic patterns. So that means if you use PHM, you can really focus on finding the periodic high utility item set. You don't need to look at all the item set that are not periodic. And the same on the other databases. Okay. So now we did some other experiment also about the execution time. We look now at the time, okay, for each database we try. And we can find here in blue we have FHM, and the other lines is the new algorithm, PHM. We can see it is much faster than the blue line. FHM. Okay, here also on mushroom, FHM is much slower than the new algorithm at the bottom. Okay, and the same on the other database. So why is it like this? Because PHM used the new theorems for the periodicity to eliminate the non-periodic pattern, and then it becomes really fast. There are some interesting observations, okay? So when we looked at the data, the real data about shopping, we find some periodic pattern, like people buy some product 32, 48, and 39 every 16 transactions, okay, for example. So here I don't have the meaning 32, 48, 39, but it means some products like milk or banana or orange and so on. Okay. And also we find that PHM can use up to 10 times less memory than FHM. It is very, very efficient. So in conclusion, today I present the PHM algorithm for the periodic high utility item set. It is a new problem, and this new problem uses some new periodicity measure called the average periodicity and minimum periodicity, and we studied their property. We presented an algorithm and we did some experiment. So in this talk I give you a good overview so you know what we want to do for the periodic high utility item set, and you get the main idea about how it works. Okay. If you want to find the code, the data, you can look up the SPMF software. You will find the code and also many other algorithms you can try. So that's all for today. Thank you for watching. Okay, bye.